Okay, the plan today, I will finish some new contents today, and then we'll do the final exam review. I'll give you some tips about how you should prepare. The final exam should be, well, maybe a month away or something. Well, just keep checking the Moodle announcement about the new exam schedule. Okay, but now let's cover some new materials. Okay. Okay, so we talked about object aliasing last time. So object aliasing is really about the addresses for the reference variables. So we talked about definitions and some small example last time. So let's do some case studies. Okay. So now let's consider two examples. Okay. So I deliberately made the two examples very similar. Example number one, there's no aliasing because we only deal with primitive values, integers in this case. And example number two, there will be aliasing because they are reference variable objects we have to deal with. Let's compare to see, even though they are very similar, but they behave very differently. And the key to solving these problems, for example, in the exam, will be to draw diagrams. I'll show you how you can do that, okay? Okay, let's do line by line, and then also use iPad to illustrate to you. Okay, so now, let's first of all consider primitive variables. Let's see from line number one. Let's say we got I1, I2, and I3. We got three variables, okay? 1, 2, and 3, very simple. Let's just try to draw what's going on here. I1, I2, and I3. Okay? So we got I1, I2, and I3. Three different integer variables, 1, 2, and 3. So that's what we have up to now. Okay? Okay, three variables here, and then we have an array, and that's how we use the array initializer over here. We're going to have an array called numbers1 with size 3. Index 1, I1, index 2, I2, index 3, I3. Okay, let's see how we draw that. The way we do this, first of all, numbers1 is going to be storing the address of the array that we are trying to create, and then it's going to point to an array of size 3. So it's index 0, index 1, index 2. Let's be careful over here. So over here, when you say I1, I2, and I3, that means you're going to copy what's already stored in I1, I2, and I3 into the corresponding slots. So how's that going to work? Basically, you're going to copy whatever that is stored. Let me use a different color here. Whatever that is stored in I1, copy that into index 0. Whatever that's stored in I2, copy that into index 1. Whatever that's stored here, copy that into 3. You can see we got different copies of the same value, 1, 2, and 3. Okay? There are no addresses whatsoever up to now. Okay? And then let's go back here. And then what about numbers 2? Numbers 2 over here, we're going to create a new array, integer array. What's going to be the size of the array? It's going to be of the same size as array numbers 1. Okay? In that case, in the beginning, all the slots are going to store the default values, which is 0. Let's do that, okay? So now what we're going to have is another array over here. So we got numbers 1, and then it's going to be of the same size as numbers 1 the length, which is 3. So 0, 1, and 2. Initially, all the values are going to be 0. So if you try to print out all the slots at this moment, it's going to be 0, 0, 0 for numbers 2. Sorry, numbers 2, yeah, right? Let me just, there's a typo here. Sorry, too big. Numbers 2. Okay? Okay, let's now go on. And now let's consider this for loop over here. So we have a for loop, and starting from 0 until numbers 1 the length, right? You can see the less than sign. So which means we're going to run 3 iterations in total. And then we're going to say numbers 2i is assigned to numbers 1i. What's going to be the values for I? It's going to be 0, 1, and 2. Agree? We got 3 iterations there. Let's just consider the first iteration. The first iteration is going to be line number 7. Numbers 2, 0 is assigned to numbers 1, 0. Let's see what that's going to do. Okay, let's see. So the first iteration over there is going to be something like this, okay? So we have numbers, okay, let's just be short. Numbers 2, numbers 2 at position 0 is assigned to numbers 1 at position 0, the same position. So what does that mean? That means we're going to somehow store something over here. What should we store over there? Whatever that is stored over here, right? So that means copy this value over here and then replace that into here. So what's going to happen is after first iteration, it's going to be 1 over here, right? And for the second iteration, will be incremented to 1. And then in the third iteration, it will be incremented to 2, right? We do similar copy, right? And then copy the 2 over here and replace it here. Copy 3 here and replace over here. Okay, it's going to be the 3 iteration for the loop. Guys, follow so far? Okay, this first example is rather easy. There's no aliasing. Okay, let's do some very easy tracing. Let's say if I put this fragment of code in the final exam, that's exactly what you should do to trace the code. So now let's say we say numbers 1 at position 0 is assigned to 4. Okay, numbers 1 at position 0. Numbers 1 at position 0 is assigned to 4. That means we're going to replace this by 4. That's what we'll do, right? Okay. And then, if you go back there, now let's say we do system.out.print line. Numbers 1 at position 0 versus numbers 2 at position 0, right? So what should be the outcome for that? So numbers 1 at position 0 should be 4. And then numbers 2 at position 0 should be 1, different values. Okay? The first one is easy, but you should know how to trace. It's just a warm-up for the second example. Any question about this before I move on to the second one? The second example there is going to follow a very similar pattern. The complication we're going to add will be we're going to deal with person objects. Okay? So now we do have some aliasing issue to take care of. So that's where you should really pay attention to. Okay? Let's be careful with the second one. Okay? Now, let's go to the second example. Let's again go line by line. So now we have reference variable, which means they're going to store addresses for the objects. Okay, line number 1, 2, 3, 4. So we're going to have 4 objects to be created. We got Alan, Mark, Tom, and Jim. Let's also assume we also got we have 2 attributes for the person class. We have name and also we have age. Okay, so now let's try to draw what's going to happen after these 4 lines. So we got Alan, Mark, Tom, and Jim. Let's do that first. Okay, let's do that. So that means Alan is a variable which stores the address of some person objects. Let's put it here. Okay, every person has a name and has a age. Okay, like that. And then notice that over here, Alan object is going to be of name Alan. Then there's no age over there, which means it's going to be the default value 0. Okay, so that's going to be Alan. And then we have 0 over here. Okay, we got 4 objects in total. Let me save some time. Okay, let me just copy this over here. Okay, we got exactly 4 objects over there. Let me try to make this a little bit smaller. Okay, still visible, right? I hope. Okay, let's now copy this 4 times, and then I'll change the attributes accordingly. Okay, so we got 4 objects here. 1, 2, and then 3, and then 4. Okay, we got 4 objects. Let's follow the order. So Alan over here, and then we got 2nd, 3rd, and 4th. We got 4 objects. Let me just review the order. So it's going to be Alan, Mark, Tom, and Jim. Okay, Alan, Mark. So the name is going to be Mark. Tom, and the name is going to be Tom. And also Jim. And the name is going to be Jim. Of course, you're going to make sure you define the constructor accordingly. But that's something very easy. You know how to do it. Okay, we got 4 objects so far. Any question until this point? So having 4 objects over here means we got 4 different addresses, right? We got address for Alan, address for Mark, address for Tom, address for Jim. So they're all different. Okay, they're different objects. Okay, let's now go for the next line. The next line over here. Okay, sorry. Okay, now let's say we got line number 5. We are initializing an array called persons1. And then persons1 is going to store Alan, Mark, and Tom. Let's see what this is going to do. First of all, we know that persons1 is going to be an array of size 1, 2, and 3. Three elements there. Each element there is going to store the address of some person objects, right? Let's understand that first, and then I'll draw what we know by now. Okay, let me go back to iPad there. So persons1. So let me just put persons1 over here. Persons1 is going to point to an array of size 3. 0, 1, and 2. Okay? So now, let's see how we can complete the rest of the diagram for that line there. Let's be careful over here. So when you say persons1 is initialized to be Alan, followed by Mark, followed by Tom, that means you're trying to assign Alan, whatever that is stored in Alan, into position 0 of this array. Assign what's stored in Mark into position 1 of this array, and etc. Okay, let me just write down one for you. So what does that mean? When we say persons1 at position 0 is assigned to Alan. Okay? This is a very critical line for you to understand over here. Basically, we are going to do some copy. Okay? What we really copy is not the entire objects, including all its attributes. That's not what we're going to do. All we're going to do is, whatever that is stored in Alan over here is simply an address. And then store the address in this particular slot. That's all we do. Okay? So now, let's just make some example over here. We know that this person object over here is going to be allocated with its space somewhere in the memory. It may have some address. Let's say the address for that is 00101. I just made it up. Okay? So now, what does that mean? When we say persons1, 0, which is this slot over here, is going to store Alan. That means we're going to just copy this address over here into this slot. So that means we're going to copy 00101. That's how it's going to work at the runtime, at a lower level. However, conceptually, you can make it much more effective for you to understand. Storing this address over here means you're going to point to this object over here. So now we do have an aliasing situation. Why? Because right now, if you try to do the following assertion, if you say Alan equals persons1 at position 0, it's going to give you true, right? Because Alan is storing the same address as the first slot of the array of persons1. They store the same address. So that means if you try to compare the addresses, they will be the same. So it's going to return true. Okay, this is really, really critical for you to see. Guys, any questions until now? Okay, and conceptually, you can think about Alan and position 0 of persons1 array, they point to the same objects. So we have seen such illustrations in your lab number 405 tutorial videos. Okay? Okay, let me just undo this. Okay? And then, if you just go back to the rest of the code, that means we're going to do similar assignments from Mark into persons1 at position 1, and Tom into positions 2 of persons1. So that means, let me just do that now. That means persons1 is going to point to this object over here. And this is going to point to this object over here, Alan, Mark, and Tom. Any questions? Guys, please, at the back. Okay, and then after this, let's go on. So what about line number 6? So now we are creating another array, and then in this case, the array is going to be of size the same as the first array. And then what's going to be the default values for that? For integers, it used to be 0, but now we talk about addresses. the default values for addresses are nulls. So that's a special values in Java. Okay, so let's try that. For this line over here, it's going to be something like this. So we got persons2. Okay, so we got persons2 over here. And then it's going to point to an array of size 3. And then 0, 1, and 2. So initially, it doesn't point to anything. Initially, all of them are going to point to null. Initially. Nothing there. Okay, that's what this line would do. So now, if you try to run a loop and try to print out every slot of the array, it's going to be null, null, and null. So the timing is really important, okay, at this point. Okay, let's see something similar. You have seen this before. Let's say we do just another loop. And this loop is almost the same as what we did before. We are trying to basically do some assignments, right? So now let's try to see this. So the loop is going to start with 0 until persons1.length minus 1, and then do plus plus. And then we say persons2 at position I is assigned to persons1 at position I. Let's again talk about the very first iteration, and then we can extrapolate to the general situation. Okay? Let's say let's talk about the first iteration. Okay? So let's now come back here. What about the first iteration? The direction for the arrows is really important. You really got to get it right. Okay? For the first iteration, it's going to be persons2 at position 0 is assigned to persons1 at position 0. That's what you should do. You see persons2 and persons1. Okay? So what does that mean? Literally speaking, whatever that is stored in the 0 slot of persons1, copy that value, which is an address, copy that into position 0 of persons2 array. That's what it means. But let's think about that. Persons1 as position 0, let's identify that. Persons1 at position 0 is over here. Currently, it is storing the address for the objects called Alan. Okay? And then what about persons2 at position 0? It is this slot over here. Right? So we're going to basically copy this address over here and put it here. Okay? So what does that mean? So let's try. So this address is 00101 as we tried to make up before. Now, conceptually, that means rather than pointing to null, this slot over here is going to point to wherever persons1 at position 0 is pointing to. So now we do have another aliasing situation right now, right? What is that? You can see Alan equals persons1 at position 0. That one is true. We also get persons1 at position 0 equals persons2 at position 0. That's also going to be true, right? Okay, so hopefully if you have already followed what we said in the tutorial videos, hopefully that wouldn't be so strange to you, okay? Okay, that's about the first iteration. For second iteration, we're gonna get 1. For third iteration, it's gonna be 2, right? Let's try that. Let's complete the diagram. So that means slot number 1 over here, rather than pointing to null, is going to point to wherever slot number 1 over here is pointing to. So that means it's going to point to over here, right? And then slot number 2 over here, rather than pointing to null, is going to point to over here. So now we got aliasing situation. You can see, without knowing how to draw the diagram, it's difficult. I wouldn't say impossible, it's difficult for you to trace. Okay, that's what's going to happen after the loop. So now let's try that over here. When you say line number 9, persons1 at position 0 dot set age 17. So what does that mean? Let me just write it down over here. So we have persons1 at position 0 dot set age. Let's make the assumption that we do have a mutated method called set age in the person class. Just change the age. Okay? So now persons1 is what? Persons1 at position 0 is talking about this slot over here, which is pointing to this object over here, right? And then when we say set age to be 70, that means we want to change this to be 70. Okay? Should I do it again? Let's do it again. So now, again, it's really important for you to follow this. Persons 1 at position 0. It is talking about slot number 0 at index 0 for persons 1 array, which is pointing to this object over here, right? That's how we know. And then we say that set age. So for this object being the context object, we're going to set the age to be 70. So we change from 0 into 70. So now, apparently after this line, we know that when we say persons 1 at position 0 dot age, it's going to be 70 for sure, right? We're talking about that object, so that's going to be 70. But not only that, what about if you try Alan dot age? Is that going to be 70 as well? It is going to be, because Alan over here is pointing to the same object over here. So that's also going to be 70, right? Not only that, can you suggest another path? Persons 2, right? If you got persons 2 array at position 0 dot age. So you're basically talking about persons 2 array at position 0, which is pointing to this object over here, the same objects. That's also going to be 70. So it doesn't matter which expression you use, because it's aliasing, that means they all point to the same objects. Doesn't matter which one you use. It's going to read the latest value for the age. Okay? So that is why when you go back there, if you say system.out.print line, first of all, what about Jim.age? If you go back to the diagram here, Jim is this object. Currently, there's no aliasing for that object currently. When you say Jim.age, it's going to be 0. Okay, that one's easy. Let's go on. And then when you say system.out.print line, Alan.age, we just discussed that. Alan.age is going to be 70, right? And also, if you say persons 2 at position 0.age, that's also going to be 70, because we talk about aliasing, right? Persons 2 at position 0, so persons 2 at position 0 is also going to point to the same object, right? That's also 70, right? That's also. And then, let's try to do one more thing. Line number 13, we say persons 1 at position 0 is assigned to Jim, right? Apparently, we are copying the address that is stored in Jim and copy that over to the 0 index of persons 1 array. That's what we're doing, okay? So how do we do that? Let me just write that line down. Persons 1 at position 0 is Jim. Persons 1 at position 0 is assigned to Jim. Okay, that's what we're going to do. And I'll use a different color in this case, okay? Okay, how do we change the diagram to update our tracing? So now, persons 1 at position 0 is basically this slot over here, right? This slot, position 0. And then Jim is this variable over here. So what does it really mean? When we copy Jim into this slot, that means this slot is now going to point to wherever Jim is pointing to, right? Applying the same logic. And Jim is pointing to this object over here, right? So what does that mean? That means like this. Let's see. Let's be careful here. You can see persons 1 at position 0 used to be pointing to this, but no longer the case anymore. Instead, it is going to point to, I'll try. It is going to point to over here, this object over here, right? Let me just try to highlight that. It's going to point like this. Like that. Remember, each variable can only store one address. It cannot store two addresses at the same time. Okay? So now, again, we got aliasing. What kind of aliasing do we have? Let's try. So after this line over here, we have persons 1 at position 0 equals Jim. Okay? So that's the aliasing we have. So after this, let's try that. When you say persons 1 at position 0 that set age, So how do we do that line there? Persons1 at position 0 dot set age. Okay? So after this, we say persons1 at position 0 dot set age. 75. First of all, let's identify what's really this object over here. Persons1 at position 0. Persons1 at position 0 is now pointing to this object over here. That's exactly this object over here. And then when we say set age to be 75, so that means we're going to change that. So this, rather than 0, is going to be 75. Okay? Okay, that's the change we're doing. But now let's go back there and see what we want to print out. First of all, what's going to be Jim.age? If you look at that, Jim is pointing to the same object over here, which has been changed for its value for age. So Jim.age is going to be 75, right? And then, if you say Alan.age, has Alan's age been changed? That's a question. The answer is no. Alan's age is still referring to this object over here is still 70. Okay, 70 remains to be the same. Okay, finally, what about persons2 at position 0.age? So persons2 at position 0. Persons2 at position 0 is still pointing to this object over here, which is Alan. And that one there remains to be 70 for its age. Okay, okay, so that's about example number 2. Any questions about this? Easy, right? It's not difficult. Good. Expect something like that in the exam. Good. Guys, really no questions? I wouldn't mind explaining more, but if you really say you're okay, then I'll pass. Okay. All right. Now, for the rest, I tell you this is what's going to be the case. We finished the 2 examples over here. From now on until the end of the slides for classes and objects, everything has been covered already in the tutorial videos or in the lab instructions. Everything has been covered. I'm going to leave you to study this. Everything has been covered, nothing new here, except for the static variables, which I will talk about right now. So when we come back for the remediation period after the strike, I'm going to review all the slides over here. So if you don't feel confident about these slides over here for self-study, you can just join the lectures. That's going to happen after the strike. Okay? But nothing new here, as I said. Okay? So you should really follow through all the slides for the rest of the classes and objects lecture. Okay? So now, I'm going to enter a new topic over here, something called static. Okay? So there is a keyword you should know if you program in Java. It's called static. Let me just talk about the concept very quickly, and then I'll give you one example. Okay? Static. Okay? So now, basically, this is how you're going to understand that. Let's say if I say integer I, integer j, okay? And now I can freely just add another so-called modifier. It's called modifier. For that, it's a keyword. Okay? So now we got 2 variables over here, int I and static int j. We got 2 variables over here. Okay? So how do we call them, first of all? For integer I, it's called non-static. Non-static variable. What about j? J is called static variable. It's very easy to see the difference. If you see a variable with static, that means it's static variable. Without a static, then that means it's non-static variable. Okay? So how's the static going to make a difference? A huge difference. Let me just summarize what the difference is, and then we'll see one example to see. Okay, so now over here, when you say j over here, okay, when I say j over here is a static variable, I would just say it's a global variable. Global variable, okay, and then over here, I will elaborate on what global really means in just a moment. And then for I over here, it's more like a local variable, okay? local variable. Let's try to be a little bit more detailed here. When I say local variable, local to what? Local to a specific context object. I'll tell you why, what it really means in just a moment. To a specific context objects. And global here, global means to all context objects. Okay, that's kind of the informal definition for static versus non-static. You can just, if you really want to memorize something, you can memorize as static means global, non-static means local. Okay, but let's see the difference. Okay, what I will do is I will type something. For those of you who got your laptop, let's try. Okay, the reason that I want to try from scratch is the static versus non-static is really tricky. So we really want to do it properly. But the source code is also available to you. But let's try. Okay, so now if you open up your Android Studio, okay, let's try that. First of all, let's create a new class over here. Let's just call it counter, make it easy, counter. And then we also get another class over here called counter tester. Okay, so we got two classes, counter versus counter tester. For the counter tester over there, we're gonna have a main method. Okay, public, static, void, main, and also string args. Okay, we're gonna run some test cases over here in just a moment. But let's first of all go to the counter class over here. Now, the way I'm going to contrast the two cases for you is to declare two variables in the same class, one non-static and the other one static. Okay, let's try. Okay, let me be careful. Okay, the first one I'm going to do, let me say we got integer. I'm going to make it very explicit for you, just call it local. Okay, so this is non-static. Non-static variable, or attributes if you like. And then the second one, I'm going to say static and integer. I will call it global. So this is a static variable. Okay, so there are only two attributes in this class. One is static, the other one is non-static. One is local, the other one is global. Okay, and then what we will do is, first of all, let's have a constructor. Counter over here, if you like, you can simply say local or this.local. Is assigned to 0. Okay, so now we have the constructor over here, and let's have two mutated methods and see what's going to happen. Okay, the first one, we can say void increments local. And then we say local plus plus. Okay, the second one, we say void increments global. And then we say global plus plus. Okay, that's it. That's it for the counter class. So we got two variables, one static, one non-static, and we also get two mutated methods. One is going to update the local variable, the other one is going to update the global variable. Okay, two methods over here. Okay, so now let's try to see exactly the difference between static versus non-static. Let's see. Yes, say that again. So what you mean? What it means by local and versus global? So, you mean in the constructor? Okay, okay, sure. Okay, that's good. So the question was, can we also put it here? Yes, you may. It wouldn't make a difference, but if that makes clearer for you, that's okay. Yeah. Okay, let's say initially both the local and global, they will be 0, let's say. Okay. You know what? Let me just comment this out just for now. I tell you what, it will make a difference. I'll tell you why in just a moment, okay? Okay. Let's now go to the tester over here. Okay? Now, let's now try to do the tester over here. Let's create two counter objects. Counter C1 is new counter, and then like that. And also we got counter C2 is new counter. Okay, we got two counter objects. And let's also draw the diagram to illustrate at the same time. We got C1 and C2. Let's now see how we should draw. So apparently we got two objects here, and also we got maybe 4 copies of local and global, maybe. But let's see if that's really the case. Let's see exactly how we draw that. Okay? So now we got C1 over here. C1 stores the address of some counter objects. Similarly, C2 also stores the address of some objects of type counter. Okay? So now the question is, how should we draw the box for each one of them? What we said before, the contents for each object depends on what attributes you have. You might think at this point we got 2 different attributes for each class, right? For the counter class. As you can see over here, for counter over here, you got local here, you got global here. So you would think we should do local and global both in the boxes. That's not true. Okay? Now, let me just put one more thing here. Non-static variable, this will be part of the object box. Okay? And over here, this is not part of the object box. So what do I mean? I'll draw it to you. Not part of the object box. Okay? Let me draw that to you. So now, first of all, let's do the local first. Local means every object has a copy. Every object. So local over here. Okay? And also local over here. Local and local. And remember the constructor is going to initialize both of them to be 0. So now C1.local and C2.local, they are different copies. They are different. So how do we deal with the global? This is how you can think of it. There's one way to visualize it. Let me use a different color. So what I would do is, the way I draw the global is to say, now I'm going to say counter over here, okay, separate. And then I'm going to put global over here. Initially, default value just 0. Okay? Let me just give you some comments over here. This is not an object. This is not an object. So this is the information shared by all objects of counter. Which means we just set aside some place over there, and then we keep track of global. There's only one copy of global, only one copy. Okay? Every time when you try to create a new counter object, you have a new copy of local. But there's only a single one and only copy for global. Only one and only one. Okay? You can see there's no pointer here. Okay? So now, that's kind of memory model you should have in your mind. Okay? So now let's try to do something more. Okay? So now in the counter tester over here, let's try that. First of all, let's do some printout. C1's local over here, and then we can say C1.local, right? That's how you do it, right? And also we can do C2.local. Okay? Let's try these first of all. And as you can see that it should be both zeros, okay? Let me just run it for the first time. So let me go to counter tester over here, and then we'll say run the main method here. Let's try that. Okay, it's now building. So now C1's local is 0, C2's local is 0, right? Okay, consistent with our diagram here. Let's do more. So now, let's try to get access to the global variable. Let's try to get access to it. So now, according to a diagram over here, there are actually 3 ways you can try to get access to the global variable. Think about that. One way is to say, because all the objects are sharing this global variable. So you can say C1.global. That one works. you can also say c2.global. That also works. But something that's kind of new to you, you can also say, I wouldn't give any context objects. I would just give the name of the class, counter.global. That will also work. That's the new thing you have to be careful about. Okay? So now, to be clear to you, before I go to the Android Studio, when you say c1.global, this will compile. c2.global, this will also compile. When you say counter.global, the class name, counter.global, this will also compile. All of them compile. Okay? Now, let's try to contrast over here. If you say c1.local, that will compile, right? We're talking about this copy over here. When you say c2.local over here, you're talking about this copy here. That will also compile. However, if you try to say counter.local, that will not compile. First of all, local over here is non-static. That means every object over here has a copy for local. If you only say counter.local, you don't really know which copy you're talking about. You should really give a context objects, like a C1 and C2. So this does not compile. Okay, let's make the difference first. Syntactically, you just cannot do it. Okay, you just cannot. Okay, so now let's try that. To access the global variable, we can definitely do it. Let's try that. System.out.println. Okay, let me just maximize this. Okay, let's say the global variable accessed via C1. Okay, over here you can say C1.global. Okay, this is okay. Okay, notice that it's okay. Okay, let's now try another one. You can also say global access via C2, and then you can say C2.global. Similarly, you can via counter. Over here you can say counter.global. That's also fine. So far, there's no compiler error so far. Okay? If you try that, let's see what's going to happen. At the moment, it's all going to show 0 over here, right? That's what we expect to see. Let's see. Okay? You know what? Let me just make a little bit more pretty printing. Call in here, and call in here. Okay, let's try again. It should be all zeros, basically. Okay, we got 0, 0, and 0. Okay? Okay, so now let's try to see the difference between non-static versus static. Let's try. Okay? Now let's try the first example. What I want to do is this. Okay? So now this is what I want to do. Let's say system.out.println. Let's say I want to update some variable over here. Specifically, I want to update this local variable over here for C1. Conceptually, if you try to change this value here, for example, from 0 to 1, it is not going to change this value. It is not going to change its value either, right? That's what we expect to see. But how do we see that? Okay, let's see. Okay, so now let's say change C1.local. Okay, how do we do that? You can say C1.increments local, right? That's actually one of the methods we just defined. Let me just do that. Okay, sorry. So let's say over here C1.change local. Did I miss something here? One moment. Increment local, sorry. Increment local. Okay, increment local. So what we expect to see is like this. When we say C1.increment local, we're only going to modify this value over here from 0 to 1. Okay? So after this line over here, if you try to get access to the global over here, what's that going to be? It's going to be still 0, right? It's still going to be 0. Let's try. Okay? Okay, so after this, let's try this. System.out dot print line. What I would do is, let's just copy these 3 lines over here. We're just going to do the same printout. Okay? Okay, we're going to see the global variable C1.global, C2.global, and counter.global. And also, we want to see the local variables as well. So these are the 5 things we want to print out. Okay? Okay? After that, so what do we expect to see then? Okay? According to the diagram, after we do the increments from 0 to 1, so now C1.local should be 1. C2.local should remain to be 0. What about C1.global? 0. C2.global should be 0. Counter.global, 0. Right? That's what we expect to see. Let's see. After this. Right? You can see that the global variables, doesn't matter how you access that, using C1, C2, or counter, it remains to be 0. And for the local variable here, you can see C1's local is now 1, but C2's local remains to be 0. Okay? So now, let's see another interesting change over here. Okay? If I try the following, okay? Let me just copy this line over here. So now change C1 dot global. So that means I want to modify the global variable right now. But how do I do that? So there are different ways for you to do it. You can basically, let me just say C1 dot increments global. So what does that mean? C1 dot increments global is going to increment the global variable by 1. So that means C1 dot increment global is going to change this from 0 to 1. You can see we are modifying a different variable over here, right? We are not really modifying a variable that's local to this particular object, not anymore. We are modifying the value that's visible to both C1 and C2. Okay? That's really the difference. Okay? So now, what's going to happen? Let's go back there. So now, I'm just going to copy all these lines over here and see what happened. Okay? So now after this change over here, increment global. If you have doubts, remember that increment global is exactly over here. It's going to say global plus plus. Okay? So now let's go back here. So now global is going to be 1 actually, right? It's going to be 1. And then what about C1.local? Remains to be 1. And C2.local remains to be 0. Okay? That's kind of how you can see it. Let's just try. Okay, you can see that after we change C1 to global, even though we use C1 to change it, but since that variable over there is global, so when you say C1 dot increments global, even though the context object is C1, but since you're modifying something that's global and visible to C1 and C2, so it doesn't matter. So when you say C2 the global, it will still be 1. Okay, it's also 1, the latest value. That's the point. In some ways, a little bit like aliasing. Idea is similar. Not exactly the same, but similar. Okay? Okay, that's about it. And if you download the source code, you will see the complete example like this. Okay? I'm just trying to give you a taste about how the static variable works. As far as this course is concerned, you have to understand what's the difference between non-static versus static variables, especially using the example there as an introduction. And then I want to refer you to the example over here in the classes and objects. I'll show you that. Okay, I'll show that to you. If you go to classes and objects slides, I want you to look at that as a case study. One used for, okay, let me just go there first. one useful application for static variables is to use it as a global ID for bank account clients. For example, let's say you have 100 different clients or 100,000 different clients in your bank. How can you somehow automatically assign distinct or unique IDs to them? And static variables can be for that purpose. Okay, so that's a case study over here. So study that before the exam. But as I said, what I would do is during the remediation period after the strike, I'm going to go over that slide as well. So make sure you also follow that if you cannot follow by yourself. Okay? Any question about static variables before I move on to the next topic? Any questions? Okay? Yes. So this is in the same classes and objects slides. So if you go there, go to slide 62, and you will see that. Yeah. Okay. Now, let's now enter a new topic over here, and that topic is rather easy. It's basically just about how you can use API. I'll define what an API is, and then give you some examples, and then I'll tell you what you should know for the exam. Okay. Okay. Let's talk about using APIs in Java, okay? And that'll be the last lecture for this course, okay? It's not really a long lecture, but we'll have some code to go over, okay? And all the source codes I'm going to present, they're also on the course websites already. You can also look at them. Okay, let's go through some concept. First of all, we want to make sure you know what API is. And also, the API is really something we definitely cannot teach you all the API. It's not just not possible. API, think about it's like a library of books. And for you as a developer, every time if you want to solve a problem, you can certainly consult with the API. I'll show you how you can. Okay? And also, we're going to talk about the concept about method signature. For those of you who actually followed the tutorial video in the beginning of the semester, I did talk about method signature. Parameters versus arguments. I'll review that again today, okay? Yeah, parameters versus arguments. Okay, and then non-static versus static. So all you gotta know about static is, if something is non-static, you have to create a context object for that. If something is static, you only need a class name to call that. That's the principle, okay? It's also on the slides, but that's something you should know syntactically, okay? Again, it's really important for you to know this kind of a comparison over here, right? When it is non-static, you just cannot say class name dot non-static variable, okay? And similarly for methods. Okay, so now, API stands for Application Programming Interface, and what's that? The keyword over here is about reusability. It's people who actually have developed something and which is almost guaranteed to be correct. And they put it there, make it freely available for you to use. That's what API is, basically. You can think about when you are developing your labs, you're developing your game class, developing your taxpayer class. Those classes can also be part of the API for somebody else to use. As long as you keep the class implementation correct, you can definitely make it available for somebody else to use. Okay? It's all really about reusability. And so where can you find the API for Java? So there's a website for that. I'll just go to their website very briefly to show you how you can explore that. Okay? It definitely will help you not just for this course, but go much way beyond. So Java API contains a library of classes. We're going to go over 3 examples today. We're going to go over math, ArrayList, and also hash map. So we'll talk about, especially we'll talk about hash map only as an example. We'll talk about how you can implement hash map by yourself in 2030, in the fall or in the summer. Okay, that's something beyond this course, but you should know how to use it, not how to implement that. Okay, so this is the website for Java API. If you click on this link over here, let's say allow. Let's see if that will bring me to, yep. So if you go to their website over there, so this is what you will see. Basically, it's a web page, got lots of hyperlinks, and then if you go there, they got all the classes over here that you can search for. So basically, you can think about as you get more experience as a Java programmer, before you solve a problem, you may just want to have a look at here if something similar or sufficiently similar has been done already, in which case you can just reuse it. Okay? But for this course, you are supposed to develop everything from scratch as a beginner. That's better for you. I'm just saying, beyond this degree, you may just want to consult with that. You don't want to reinvent the wheel. Okay? Let's just go back and then just go over. Okay, let me just close that. Okay. Okay, you can go to the website there. I'll show you some snippet, some fragment of the pages in just a moment. Okay, every time, let's just have one example. Every time, if you decide to use a library class, you must use the import statements. So in your controller classes for every lab, you have seen the import statement a lot. You might be wondering what they are. Basically, every time you put an import statement there, that means you're reusing somebody else's work. Legally, of course, right? So now, for example, the first line of my class, I can say import java.util.ArrayList. So this is the class I'm trying to use called ArrayList, which belongs to part of the utilities package in Java. And then, let's say my class over here, I can define an attribute called myList and of type ArrayList. If you leave out the first line, there's going to be some compile time error because you haven't imported that yet. Okay? That's just one example. Make sure for every library class that you use, you make sure you import them. Okay? And also now, for you as a beginner, you want to develop everything by yourself. That's why in the labs or in the lab test, I said you cannot use ArrayList, you cannot use hash map. That's for a reason. But once you go beyond many later courses, you definitely want to consult with the API. Okay, that's for sure. You as a beginner, you shouldn't. But once you get a more experienced, don't reinvent the wheel. That's really the rule of the thumb. Okay, that's just some concept over here. Okay. So now, again, let's just go over. You can definitely read the slide. Let me just talk about the critical points very quickly. So what's a method? A method is a named block of code, reusable. So now, in the case of using API, so now, for example, there's a math class which has a square root sqrt method. Okay, for you as a user, you don't have to know what the implementation is. The implementation is completely hidden from you. For you, you just have to know how to call that. That's all you got to know. Okay. And then there are two kinds of methods you might see. I'll give you examples for both. One is called static method. So static methods, like a static variable, you can simply call that using the name of the class. You don't have to create a context object. You don't have to, even though you can, but you don't have to. Okay. So now, for example, in the math class, actually math class is a special one. All the methods there are static. I'll show you some snippets in just a moment. So all the methods in math are declared as static. That means you can simply use a class name math.square root and put something there. Okay, that's what you can do. Okay. Now, the non-static method will be more commonly the case. Okay, and we'll see HashTable, we'll see ArrayList. They must be called on the context objects. For example, let's say over here, it is illegal for you to say ArrayList.add. Add is a method in the ArrayList, but it's not legal to do so because add is not static. Okay, so what should you do? You should really, first of all, create an ArrayList object called list, like how you create a person object called Jim. And then you can call list.add, like how you call Jim.getBMI. Similar. The ideas are completely consistent. Okay? Okay, you should really know the difference between using static versus non-static. And then, what about a class? A class is simply just a collection of such methods. Okay? So every time, if you go to the API page for a particular class, they will show you a summary of all the methods that you can use. I'll show you. Okay? We got 3 examples for you. Okay? Let me just talk about one more thing. Parameters versus arguments. You can definitely read the slides. Let me just present a simpler example for you, and then we'll skip that one. Okay? You can read it. So now we talk about parameters versus arguments. Okay? So the best way to understand this is think about the following. Let's say we got 2 different classes, different domains, okay? Different classes, different worlds in Java. Okay, over here. Let's say over here we talk about developer. developer or supplier. And over here, we talk about user and also clients. We got two different sides, okay? So now, you as a developer for Java, you have developed a class. For example, you can say class over here. Let's say my class, okay, like that, okay? Let's say we simply got integer I as an attribute, okay? And then we can have mutator, we can also have accessor. Let's just try both. Accessor, you can say integer get value. Okay, like that. And over here, you can simply say something here. Okay, I'll just leave the implementation to you. It's very trivial. And then we also got a mutator, void set value. And then over here, we can also say integer, let's say j. And then, let me just be a little bit more specific here. You can definitely say I is assigned to j. Okay? Now, that's it. Simple class. And now, let's talk about, let's say somehow you make this class available to other people for use. So now, let's have another class over here, class, let's say my class user or tester, doesn't matter. And then over there, you also get a main method here. Oops. Okay, like that. Okay, let's try. First of all, you can say my class, let me say object 1 is new. You know, my class, let me just leave it empty. Okay, so now how can I call the method? I can say o1 dot set value over here to be 3. Okay, and then of course if I say o1 dot get value after this, it should be 3, right? Very easy. So now let's clarify the terminology. Okay, now when you talk in the context of the supplier over here, so we talk about supplier, and then the supplier is going to define the set value method where they talk about if you want to use this method here, you must pass as input some integer value j, right? J is just some name of the parameter, okay? So in this case, it's called parameter. It's called input or it's called parameter. So whenever you talk about parameter, it's just a variable. It's just a variable, not value. Okay? Okay, and then you can see J is over here. Okay? That's about the supplier side. What about the client side? The client side is like this. Let's say we talk about the client over here, and then we have a context object over here, and we are calling this method here, which is defined over here. And then we're giving a specific value for calling this method. And then over there we talk about arguments. So we say this is the arguments. And it's a value. Okay, you should really know the difference between parameter and arguments. Whenever you talk about parameter, you talk about the variables in the definition for the methods. You talk about arguments, you talk about the specific values you give in order to call their methods. Okay, parameter versus argument. Questions about this? Okay, and for that slide, you can just read it over. I don't need to repeat. Okay, what about a signature of a method? Basically, the signature of a method, if you go back here, if you look at this method over here, basically everything, let me try this. Everything before the opening and closing brackets, we say that opening and closing brackets is the implementation for the methods. But now, before that, what do you have? This is the return type. And this is the name of the method. And there's no parameter, empty list of parameters. So that's a signature. So the signature contains return type, name, and also parameter list, which can be empty. Similarly, what's the signature for the second method? It's like here, right? Return type is void. So that's why it's a mutator. And also the name of the method, and also the parameter list, which has only one parameter, right? That's a signature. So signature, parameters, and arguments. Okay, again, you can also read this over. Okay, now, what we're gonna see examples. We're gonna see 3 examples. In Java API, the method summary section lists signature only, which means when you look at the API for the Java library classes, they do not give you the Java code for the implementation. They only give you the signatures, which will be enough for you as a user. For you as a user to use the methods, you don't necessarily have to know the implementation. If I want to do scanner dot read the next integer, I don't have to know how to implement that particular method. I just have to know how to call the method. Okay? Let's see examples. Okay, we're going to see 3 examples here. The first one is going to be very useful for those of you who are doing chemistry, physics, or any other science major. Basically, any formula that you can find in the textbook can be implementable using the math class. Okay? They got many methods over there. They got trigonometry, they got square root, they got logarithm, they got exponential, they got lots of methods there. I'll just show you some examples. Okay? So if you click on the name over here, you will go. They will bring you to the methods. Let me just go there first. Okay? So there's a class math over here. And then one thing to notice, I want you to notice over here. Can you have a look at this section called method summary? Okay? And then you will see that over here, they only list the signature. So this is one example signature. Okay, let's try to read it together. Okay, it tells you ABS is going to return an absolute value. There's a summary. So ABS, when you call the ABS by passing a single argument to the parameter, which can be double, right, in this case. And then it's going to return a double. Okay, that's how you read the signature. And now, what's really funny over here is the static over here. Static simply means if you want to use the ABS method, you do not have to create a math objects. You do not have to. You only have to say math.abs. Okay? Let me show you why. Okay, let me show you exactly what I mean. Let me go to iPad over here, for example. You can see that you can simply say math, which is the class name, dot abs. For example, if you say minus 2.5, you can expect the 2.5 to be returned, the absolute value, right? You don't have to say, for example, math m is assigned to new math. And then you say m dot absolute values minus 2.5. This will work, but it's overkill. It's not necessary because the ABS over here is a static method. Okay? So basically, all the methods you can find for the math class, they are static. Okay? That means you just can use the class name to call them. Okay? And now, one more thing to show you over here. Have a look at something here. So over here, we got how many methods here? We got method number 1, method number 2. Over here, method number 3, and method number 4 over here. So look at that. You can see that the name of the methods are the same. However, this is allowed. This is something called overloading. Okay, I'll just explain that quickly. It's called overloading. It's also on the slides. So what does overloading mean? So now we talk about absolute value over here. It can be a double here. Let me just be precise. What was there? Double float int long. So we talk about the same method name, the same. ABS, ABS. And then A, and A. Okay? You can see that over here, the name of the methods is completely the same. Completely the same. Okay? That's the case of overloading. But now, the thing is, how can a computer distinguish between different cases? How can they do that, right? So now, whenever you got, so you can see that well, we just write it right on the principle over here. When multiple methods have the same name, then, so now in that case, in order not to have a compiler time error, so either of the following should be true. Either they have different parameters, different number of parameters. They have different numbers of parameters. Okay, that's either one, either this or they have the same number of parameters, but the parameters have different types. Same number of parameters, but different types. Okay, either case 1 or case 2. So now, if you look at the case for the absolute value, is it case 1 or case 2? It's case 2 over here, right? You can see this version here, 1 parameter, just 1. This one, also 1 parameter, also 1 and also 1, but they have different types. So that's okay. Okay? Let me give you one more example. One more. Okay, one more example here. Let's say if I say class over here, let me just call it my class. Actually, you have seen this in a lab 5 tutorial video. Let me just draw a connection to it. Let's say I got a student management system, right? And then let's say I have this. Void, let's say set mark. Yeah, I think that's the methods. Oh, no. That's what I meant to say. Add students. Okay, and also, and here we can say students. Okay, okay, and then of course you got something here. And then we got another method here, add students. And then we can just give some information enough for you to create a student objects. I believe you got string, the name, and also maybe integer, the marks, something like that. Okay, in this case, we also got overloading because you can see that as students, they have the same name. Okay, so now, would it be a compile time error depends on whether we satisfy case number 1 or case number 2. Okay, in this case, we're lucky because for this version over here, we got 1 parameter. And in this case, we got 2 parameters, so they're different. Okay? So they're different. If you like, you can also try this. You can also say void add students. And now let's say we only want to give the name of the student. You can say string and s. This is also fine. You can see that even though this is also 1 parameter, but the type has no confusion with the students, so that's also fine. Okay? So that's about overloading. Basically, for overloading, you have the same name for the methods, but what you have to make sure is the parameter list must be distinct. Okay? Any questions about this? Okay, let's go on. Okay, you can just read method overloading here. Okay, exactly what I said. So now, the case study over here is very easy. Okay, basically, let me just tell you what it's going to do. Basically, you're going to read over, you can read the problem yourself. You're going to call the method random, which is a method for generating some random number. Okay, so this is the API for the random method. You can give it a try, and then I do have an exercise for you. You want to figure out Once you get math.random, random is a static method over here. You can see that over here. So that's why you can say math.random, that's class name. So now, the question is, should you use this one over here, or you should use this one here? Give a try on this example over here. Figure out which one you should use and why. Okay, that's an exercise for you. Okay? Okay, so now, we got 2 more examples to show you. So now, in the case of the math class, because the random method is static, in the case where it is not static, you cannot just use a class name to call. You must create some context objects. So let's see. Okay? So the way I'm going to do this is, I'm going to leave the reading of API really to you. I just give you one example, just give you enough intuition about that. Okay? So now we're going to use 2 examples to show you. One class is called ArrayList. So you can click on the link, and then you will see ArrayList. Okay? When you see the ArrayList over here, they got some description over there. The critical thing is, it's called resizable array. So when we talk about arrays in this course, once you create an array, the size must be fixed. But for the ArrayList, it does provide to you the convenience of resizing it automatically. Okay? It will be done under the hood. For you as a user, you don't have to worry about how they do it. But in 2030, if you take it with me, I'll let you implement that by yourself, which is fun. Okay? But let's not worry about that for 1022. Okay, you can read it over. I'll leave them to you. But I'm just going to discuss the critical method with you. Okay? You can see the method summary over here. So you got lots of methods there. I will just discuss the common ones. Let's see. Okay, so now these are the methods you should at least know. You should know how to call the size method. Notice that the method here, there's no static associated with it. So that means you cannot say ArrayList.size. You cannot say that. You must create an object first and then call that. Okay, I'll show you. And then you also have to know the add, again, is overloading, right? 1 parameter versus 2 parameters over here. And also we got contains, we got remove, we got index of, also we got get. So these are the methods you should know. But let's see one example which will put all of them together. And the example is also on the course website. Okay, let's read it out together. Okay, so there's an ArrayList tester over here. So let's see the first line. The first line over here. Okay, let's see what's happening here. So syntax-wise, whenever you want to use the library class, especially for ArrayList or HashTable, they're so-called collection library. We'll talk more about why you have to do this syntactically in 2030. I'll explain to you. To understand this, you have to understand inheritance and generics, which we'll talk about in 2030. But for this course over here, all you got to know is, for you to write it out syntactically, first of all, give the name of the class. ArrayList. Okay? Remember, think about how you do that for the normal array. You will say integer array, and then you put the brackets like that, right? So now, somehow you have to put the type for the member somewhere. So you got to use angle brackets over here, like that. Okay? Now we are saying that every element in the list is going to be a string. So we'll put string over here. Okay? And then put the name of the variables over here. Okay? And then it's assigned to, and then we use a new keyword. And the meaning for the new keyword is exactly the same as before, just the same. It's the syntax that you have to worry about. Okay, and then we can say ArrayList, and then of type string. And then let's say empty parameter list. That means empty. Just create an empty list. So now after this line over here is going to be an empty list. Okay? So now let's see how we can understand this. One more thing to remind you about. So when you talk about ArrayList, the indices also start with 0. Okay? It's also 0. Be careful. Okay? And then I will illustrate to you what do I mean by resizable. Okay? So now let's go line by line. So now let's look at the next 3 lines over here. Okay, first of all, we say list.size. Let's say what we're trying to call. The size contains index of. right? So these are the three methods over here, okay? You can see that for the size method over here, according to the API, the size method here takes no inputs, just leave it empty. What about for contains? You will take some something over there, just pass the object that you're trying to store. And also, you also get index of, which will tell you where the object is. So for those of you who have seen the Lab 5, index of should not be too strange to you, okay? So now let's see how that will apply. Initially, so here we talk about empty list. Still is empty list. So now, when you say list.size, it's going to give you 0, okay? When you say list.contains, do we have that elements there? We don't. We haven't got anything yet. So it's going to be false. And then list.index of is going to be -1, like exactly how we did it in the Lab 5, -1 initially. Okay? Initially just empty. You can think about initially, well, let's draw the diagram to trace. List initially is simply just empty. Not now, it's empty. Okay? So now, when you say list dot add A, what's going to happen? It's going to add as index 0, add A to it. Okay? When you say also here, list dot add B, and then it's going to just grow it, conceptually just grow like that, and then add B to it. Very easy. Of course, the way we did it for your lab number 5 is by implementing this using the array and the counter. It's a different way of implementing this. If you choose to use ArrayList, which you made, in that case, you can just use it without a counter. Okay? But for the lab test 3, you cannot use this. I'm just saying that you should really always read the instruction. I may or may not let you use it. Okay. Okay, after this, so now let's try that. So we got a series of printout statements. So now, when we say list contains A, yes, right? True. List contains B, also true, right? A and B, they are there. And also list contains C, no. So it's going to be false. Okay? List index of A, 0. Okay? Index of A is going to be 0. Notice that is really important. Once you define this list over here, it's going to be used as a context object for every of the method call, right? Context object. Notice that. It's really important. What about the index of B? 1, right? It's 1 here. What about index of C? C doesn't exist. -1. Okay? So now let's do another one. Let's now do another line here. List.add C over here. So that means you're going to grow the list C at index 2. Okay? And you can figure this out, right? Okay, now contains A, yes. Contains B, yes. Contains C, yes. So true, true, and true. Index of A, 0. Index of B, 1. Index of C, 2. Okay? One more. So now I'm going to illustrate to you what do I mean by resizable. So now, this line is really critical. When I say list that remove C, okay? If I say that over here, conceptually, it's going to remove C from here. It's going to wipe it out, basically. Just like that. Conceptually. You don't have to know how it is achieved. So after this line over here, what you will have is A exists, yes. B exists, yes. C, false. It doesn't exist anymore. Yes. Good question. You know what? I'll get there. It's a very good. I'll just get there. Yeah. Let's just finish this, and then I'll get back to your scenario. And then index of A will be 0. Index of B will be 1. Index of C will be -1. Okay. Okay. Let's try something different. You can also verify that using Java, using Android Studio. Let's say this line over here. Hypothetically, let's consider let's say used to be C here, used to be. If I say list dot remove B. Okay? So now if I do that, you can think about, it's going to be something like this. You're going to wipe this out. And then somehow conceptually, you're going to put this, you're going to put this, join it over here, and then somehow change the indices over here to be the right sequence again, 0 and 1. That's what's going to happen. Verify that in Java. Yeah.
The add function.
Yeah.
I see it as an integer and then C. What is
Oh, good question. Good question. Yeah. So guys, there's something I forgot to mention. Yeah, good. So there's one thing I forgot to mention over here. Let me just say that again. Add over here, yes. Okay, forgot about that. Very good. Guys, you know what? Let me do it again. I didn't do it so precisely. Let me just do one more time. Okay, it's very good that you caught that. Okay, let's do it again. Initially, empty list. Initially. Okay, let's say list.add A. We just add A over here. Index 0 and then A. And also list.add B. We just add B over here. So now notice this line over here. So remember the add method was overloaded, which means that we got different versions over there. Let me just show you the two versions over there. You can see the first version there, we simply just pass the elements we want to store in the list. The second version is, where do you want to store the elements in terms of indices? So now we're using the second version over there. Okay, let's try to see that. This is what we're trying to say. Add element C at index 1. But index 1 is already occupied by B already. So what we're going to do is insert that into index 1. Shift everything to the right. Okay? What's going to happen is like this. Okay? I'll try to mimic the way it's going to do conceptually. So now we're going to, first of all, make some space over here. Shift this to the right somehow, right? And then make it in the middle at index 1, and we want to do C over here, right? And then update this index to be 2. That's what we're doing. Okay? Make sense? And then, so now that's why when you say list.remove C, if you want to remove C over here, that means you're going to remove this, and then this will be completely gone, and this will be reset to 1. Okay? That's what's going to happen. Oh, okay. The question was like here. So over here, you can see that over here. Guys, could you? Okay. The question was, what can be this type over here? Okay, this type can be any class name. Yeah, within the angle brackets. So this can be string. It tells you that every slot of the array list is going to store a string. Or what can be the possibility? I don't want to get too much detail into this. I would say for the purpose of the exam, you only have to know about string, I can tell you. Okay, but for your knowledge, you can pass any class name over here. Any class name. Any. Okay? Meaning that you can have an array list of person, an array list of compute text or game or bank, right? Okay, we'll get to more about what's really the reasoning behind this kind of notation in 2030. It will require quite a bit of lecture to explain, but we'll get there. Okay, and then finally, how can you print out the elements in the array list? Pretty much like how you did before for array. You're going to say loop counter I initialize to be 0, and now rather than length, you're going to say the size, right? And then you can use the get method, okay? Get and then with the index. Any question about array list? Okay, one more example and then we're done. Okay, one more. So one more example about another class over here, which is also very commonly used, and which is called HashTable. And if you click on the link over here, you will also see the HashTable class. Okay, and now again, for this course, you don't have to know how this HashTable is implemented. I will only give you some intuition about how you can use it if you want to use it. Okay, so now the way we can think about it is like a 2-column table. Okay, and then we got keys and values. I'll just illustrate to you. Okay, so these are the methods you're supposed to know. Size, also we got key and value. So there are two notions over here. One is called key, the other one is called value. And one thing you should really notice is, whenever we talk about keys in the table, the keys are used to search the values. Okay, I will illustrate to you by using one example. Also we got get, and also we got put, and also we got remove. Okay, let's see how we can use it. Okay, okay, let's see this example here. Again, the code is available on the course website. Okay, now let's see something here. So now, first of all, this line here. Okay, now I'm going to write it out on a side over here. So now you got HashTable, I'll just say HT. And then over here, angle brackets. So now we got one thing here and one thing there. So we got string and also string. Okay, and then we get the name of the variables. Okay, like that. And the rest of the line follows what we know about for ArrayList. So what does that mean? So this is the type for the keys. And this is the type for values. Okay? So now, let's see what we want to achieve. Initially, it's going to be empty map, empty table, empty. Initially just empty. Okay, nothing there. So I'm going to say it's called grades over here. Grades is going to point to some empty table. Okay? So now, and you can think about, you know what, let me make it a little bit easier for you to understand. Let's think about this as a header for the table. One is called key, the other one is called value. Initially, there's no row over there. Imagine you're trying to do an Excel spreadsheet, right? You got a column titles, key and value, but nothing there, just empty. So that's why you will see that over here, grades.size will be 0. Contains the key value ln, false. Contains the value b plus, false, initially. Okay, let's now see how you can expand the table. When you say grades.put over here, and then I want to insert the key ln and the value a. So what does that mean? That means I'm going to do something like this. That means I want to insert a new row over here, and then I have ln as a key, and also a as his grade. Okay, as a grading table. So that means if you want to, so you can think about, we're trying to use this table here to store the information about a student's marks or grades. Alan, he got A somehow, right? And then the next line, we got Mark and then B plus. That means we got another row over here, and we have Mark, and we have B plus. Okay, third one, we got Tom, and then we got C. Okay, so now, so far we got 3 different rows in the table, the green ones. So now, this over here, grades.size should be 3. So does the table contains the key Alan? Yes, it does. Does it contain Mark? Yes, it does. Does it contain Tom? Yes, also true. Does it contain Simon? No, false. Okay, you can see that, notice that we say contains the key. So key is over here, that's a key. Okay, similarly, we can also say contains the value. Does it contain A? Yeah. B plus? Yes. C? Yes. What about A plus? No, right? There's no A plus there. Okay, So now let's try to look at also over here, how do you get to the value for a particular key? So over here, when you see get, so get is also a very important method there. Get, okay? The parameter for the get is going to be some objects, in this case a string. What's going to be the associated value for Alan? A. What's going to be the associated value for Mark? B, or B+. What's going to be the associated value for Tom? C, right? That is why what you will get is over here. For Alan, you will get A. For Mark, you will get B+. For Tom, you will get C. What about Simon over here? Simon does not exist in the table. It's a little bit like this. So index of, it should be -1. If you try to get some value of some non-existing key, you will simply return to you null. Okay? When you try to program, you will see it's going to be null. Okay? Now, over here, what about this line here? Grades.put, marks, and then F. Okay? So now you can see that mark already exists over here, and then you're trying to basically overwrite. When mark already exists, that means you're going to overwrite. Overwrite the value from B+ into F. Right? That's why after this line, grades.get mark is going to give you F. Okay? Now, finally, let's get here. Grades.remove Alan. That means we're going to remove the entire row that is associated with the key Alan. Okay? How do we do that? Well, easy. Wipe it out, like that. So Alan no longer exists. In that case, when we say grades that contains key Alan, that should be false. Alan does not exist anymore. And what's going to be the associated grade for Alan? Null. Okay, so that's a very quick example to show you how the hash table can work. I'll try to give you some more exercises, maybe before the exam, so you can also practice. Okay, you definitely want to study for these. Any questions? Questions? Oh, so you know what? For the hash table, you can only change the value, you don't change the key. You can only read the entire row. Yeah. Yeah, so that's, for example, let's say here, that's exactly what this line was doing. So you can see this line here, right? This line. You can see mark over here already exists, right? Mark already exists over here. The grade initially was B+, but now you're trying to override it with F. That's why you see F is a new value. Right? That's how you do it. Okay? Any questions about this? You know what? Okay. So basically, this is what you can assume. One key corresponds to one value. Yeah, that's something you can assume. Yeah. In the exam, I wouldn't give you something too tricky. As long as you understand how these things work and you can trace, then you'll be okay. Yes. So the question was, let's say over here, right? Okay. So now you can, let's try to be a little bit more careful over here. If you try at this point, because we know that Alan has been removed, so when you say grades.get, okay. So when you say grades.get over here, when you say Alan does not exist anymore. So if you only talk about this expression over here, Alan doesn't exist. But grades does exist. It's a table, right? So that means this is going to give you null. That part is okay. How can you get a null pointer exception? So if you go to the string class in Java API, one of the methods you can call on string, for example, you can say character at, for example, 2, right? If you try that over there, you're trying to call the method on a null pointer. In that case, you get a null pointer exception. That's how you get it. But just that expression alone wouldn't give you a null pointer exception. Okay? Guys, any questions? That's the last